Hello everyone, good morning. As you know, my name is Aubrey, and today I'm going to be talking about a meta-analysis that reviewed different current theories and research in the field of neuroimaging for language acquisition. So these two people, Elise Wattendorf and Julia Festman, took a look at what was out there. This was in 2008, so recent research, but they kind of summarized some of the key ways that people are using technology right now, neuroimaging technology, to look at language acquisition, and then also gave some of their recommendations for how to improve that. So that's kind of what we're going to look at, is the ways that it's still lacking, the information that we're still kind of missing. Okay, so these are some of the different things that we can look at with neuroimaging. So some of the different factors that play in what we see and in the way that we can measure activation in the brain. So obviously the age of second language acquisition is extremely important, as we've talked about. Proficiency is something that they really focus on that's very difficult to pin down. Developmental stages also have an effect, so we talked about sensitive periods and the way that your brain is developing on its own as well as your language developing. Circumstances of acquisition are very, very varied in people. So whether they lived in a monolingual household maybe, or the bilingual household, whether they were immersed in the culture or just took classes, all of those things are difficult to fill out on a form when you're looking at subjects and trying to compare their results. And then the type of linguistic task used. We need to pay more attention to these things. That's sort of their idea, is that we're getting better, but that in general some of the tasks previously were too vague and not specific enough. In the past, as you may have heard, it was a lot more difficult to do these types of studies. You had to wait until someone maybe passed away, and then you could take a look at their brain, see if there was a lesion somewhere. You're all familiar. Now we can use better technology, although these are still very cost prohibitive, and so it's difficult to use these. So when we do use them, we want to make sure that we're doing all of the pre-work to really fully utilize those. So what do we see? We can see that there is, in these new technologies, we can see a more broad scope of the brain instead of just focusing in on one area. So that's useful. And in general, people are starting to think that the whole brain works together, not just one part by itself. So we're able to see that better with the broader brain scanning. And then, so the activation is usually seen by blood flow, because they are able to see when there's more blood flow, which means there's more activity happening in that area. So this is kind of just a broad claim that we all may be familiar with, which is that early bilinguals rely on this kind of implicit, more automatic usage of both of their languages, and then also languages that they learn later. They're more able to, if you look at their L1s and L2s, they're more able to speak without kind of taking time to think about how they need to arrange the grammar, and so we see that with lower lexical decision times and fewer errors, whereas we had this idea that late bilinguals use more of a declarative memory, and so by late bilingual we mean after the age of 6, starting to learn the language after the age of 6. That's the definition that they used in this paper. So this is the difficult part, teasing apart the different effects. So age of onset effects, as I said, after the age of 6. So we have seen some differences in regions of activation as well as gray matter density having to do with age of onset. So there's one hypothesis that says that children who are early bilinguals have more of a bilateral activation in both sides of their brain, and then that continues for more languages as they learn, if they learn L3, L4 later in life, but that those that start later have a more localized in the left hemisphere activation. And so it's possible that learning it earlier makes it easier to learn later. I know some of these things seem intuitive, but we try to back it up with actual data. Another hypothesis that we've seen is that children who start learning languages earlier are able to, they still have more neuroplasticity in their brains, so they're able to develop more gray matter, which then helps them later on. Overall, we do see that there is more gray matter in general for bilinguals, so that's kind of what we were talking about, that maybe there's cognitive benefits to learning a language in general, but that learning earlier does seem to have an effect here, before they hit puberty, before things start to cement in place. And okay, so that was a few things having to do with age of onset, a few things that have been hypothesized, found so far. And so looking at the effect of proficiency, so some people have found that, as we said, different brain regions, people who have low to moderate proficient bilinguals, they have different brain regions lighting up, so there's kind of more activation in different areas because it's not as automatic as we said. This also could be because of the anchoring hypothesis that we saw earlier, but we don't know exactly for sure. So possible causes are that maybe they're using different parts. They're using the different part of their brain for the pragmatics. They're kind of having that declarative memory. They're remembering back what was the grammar rule. Whereas highly proficient bilinguals, so remember we're talking about proficiency, not age here, highly proficient bilinguals show that they're just using a more localized area to process. Okay, so when we compare low and high proficiency, we see that, this is what we just talked about, that some areas are, late L2 speakers with low proficiency rates have the non-overlapping activation, as we mentioned, and higher bilateral activation, so it's more all over the place when we have a higher proficiency with late L2. So, as I said, there's a big may here. It's all a big hypothesis, really, that it could indicate that the speaker's increased proficiency leads to a more like holistic, and then that there's more maybe chunked processing happening with people who have low proficiency rates, but it's all still very difficult to tell because, especially with proficiency, there's no standardized ways. They have some standardized tests that they have people take for languages, but as we learned from some of our presentations in our other courses, the proficiency tests are very difficult to administer if you're not a native speaker of that language. If you speak a very specific regional dialect, maybe they don't have a test that really properly represents your competence in that language. So proficiency is very difficult to test for, and these two researchers are advocating for more standardized ways of making sure that we're actually comparing apples to apples here. So they're saying that rather than having this be a confounding variable, it really should be controlled for as a separate variable. Okay, cognitive development, as we mentioned, someone's brain is also developing at the same time as their language ability is developing, so development that their brain is under. And linguistic tasks. So we found that overall there's less activation with comprehension tasks. This may seem kind of intuitive, and there's greater activation with language production, so it's easier to understand something than to produce. That's just kind of an overall finding in most studies. And they also, I wanted to mention some of the ways that they were studying age of onset effects. And so they were using lexical search and retrieval tasks, so given a kind of abstract context or concept, they had to come down to a specific word. Grammatical and syntax judgments, and sentence production, word and sentence repetition. So they were measuring grammaticality as well as like prosody. So in French, were you pronouncing that S when you shouldn't be, things like that, and picture naming. And so they didn't mention this, but in my opinion, they should be also taking into account the complexity, the computational complexity necessary for actually understanding the meaning of a sentence, whether there's cross-serial dependencies and things like that, as well as language typology. So if you're switching from head initial to head final languages, things that may be having a little bit of an effect on the way that someone is processing, depending on what their L1 and their L2 are. Okay, so in general, they think that the categorization of grammatical processing has been too general. That's like kind of just what people mention sometimes in their studies. They say, okay, on grammatical processing, they were having more difficulty or less difficulty, but they believe that we need to even have more further defined levels within this, and depending on the actual cognitive resources needed to understand certain grammatical tasks. And so they did mention that it's getting better, right? People are starting to have more focused tasks, which allow you to investigate the specific language processes, but that some of the results that we have in the field currently, whether or not we should really be giving them weight is kind of under up to the researcher, but that we should be careful about including some of these findings. So in conclusion, we need greater attention to the type of linguistic task, as well as a more standardized psycholinguistic classification. So when they're getting ready to do these very, very expensive neural imaging, they should really take a lot of time to make sure that they are having a standardized classification of their subjects, so that we have that data available to them. They often mention that, okay, this study and this study mentioned what age their participants were, but they didn't tease apart the proficiency, or they didn't tease apart, what the L2 and L1 and how that could have impacted the results. So doing more work up front to make sure that these things are accounted for would give us better results. And so we need to, as I mentioned, tease apart proficiency, take a look at the sophistication of their language training and knowledge as well. If they have gone to private international schools all over the world versus a public school, maybe they also just have a different way of understanding language. They have more advanced comprehension skills. And as well as the developmental phases of the brain, modality of acquisition, so formal versus naturalistic, manner of acquisition, what types of discourse have they been exposed to? So is it purely television at home on their own, or were they taken to see? Were they given more advanced texts and novels to read, and then also the typological distance of the two languages. So if they're in the same language family or not. So all those things really need to be individually addressed before we can take a look at these other results. So yeah.
Thank you. Thanks for this broad overview. Questions? Your questions. So let me just mention that in addition to the two techniques that you mentioned, namely magnetic resonance, functional magnetic resonance, and PETs, right? And these undoubtedly involve very expensive machinery. There's another technique that is very cheap, which is EEG, and probably they don't mention that. EEG is electroencephalography essentially, and that just requires equipment for EEG that every doctor, almost every doctor has, not quite, but that is also very useful because it allows you to have a very precise temporal resolution, whereas the problem with these techniques is that they give you a very good spatial resolution, so you know exactly what happens voxel by voxel, but the temporal resolution is very poor, and memory is very fast, so that these are the techniques are especially useful. And they have been used for issues concerning person's mental position.
I think, maybe I didn't mention, I think that they were purely looking at neuroimaging, right? So would that fall under imaging?
Well,
sure.
It's
maybe that's why they didn't include it, is what I'm thinking.
Because what you get is a particular, function for each particular spot. Essentially, that looks at the variation of the electric potential, essentially, right? And then you can elaborate that and get an imaging-like image. In any event, also the images that you see with these other techniques are computer-based, right? It doesn't exactly correspond to what happens in your brain, and then you can set up the thresholds in such a way that if you set them up in a certain way, you see that everything is active, right? The whole brain is active. Then if you have a higher threshold, then you see that only certain areas are activated, but that depends on your decision, right? So it's a way to make sure that you don't get the result that every single area is activated. We use our whole brain, in fact, whatever we do, but the matter is a slight difference of activation which emerges by using different thresholds. So in any event, by using EEG techniques and ERP, I don't know if anybody's giving presentation on ERP, no, not immediately. You can have a general image of the brain, but with a relatively bad spatial resolution. Whereas you can follow how the potential develops millisecond by millisecond. So there's an excellent temporal resolution. So the two types of techniques really complement each other.
Okay.
Very interesting.
Interesting. I know that PET as well uses kind of like an X-ray, uses radioactive, so there's ethical concerns as well.
PET is very useful to diagnose tumors or things like that. It's not ideal for the kind of thing because you have to get an injection of radioactive.
Yeah, exactly. There's ethical. You have to
contrasting liquid, which is not entirely obvious. Whereas fMRI, probably some of you did the magnetic resonance, not necessarily the brain, but some other, but the organ is much simpler and doesn't involve that aspect.